The Mongolian steppe operates as the site of the world's largest natural, large-scale livestock management system. Spring marks the critical biological window for herds to recover energy reserves after a grueling winter. Grazing zones are continuously rotated to prevent the ecological overloading of the fragile steppe vegetation.
Keep the herd moving forward. Go on faster now!
Equine reproduction is naturally synchronized with the emergence of nutrient-rich spring grasses. The survival rate of newborn foals directly dictates the economic output of the entire agricultural year. Controlling a herd of tens of thousands requires an uninterrupted, mounted spatial tracking network. Melting glacial streams provide essential mineral deposits for pregnant and nursing mares. Sustaining such massive biomass necessitates foraging across millions of hectares of open pasture. Grazing boundaries are defined by ancient customary agreements to prevent resource conflicts.
The valleys are rich this season. Your herds are strong. They are, but the Western Lord wants a share. We must discuss our
This
strategy.
seasonal shift initiates a strictly managed, four-season closed-loop agricultural cycle.
Move! Move! Keep the pace! Bring the rear up. Do not let them stray.
Surging summer temperatures force continuous mass migrations to secure larger, reliable water sources. Moving the animals in colossal, unified blocks optimizes navigation and overall herd velocity. Extreme livestock density demands precise calculations of each pasture's biological carrying capacity. Mechanical herding techniques are applied to guide the animals by exploiting their natural flocking instincts. Driving the horses into riverbeds effectively lowers their core body temperature and controls external parasites.
Hup, hup. Keep going, get up there.
Equine milk harvested during this peak phase contains the highest concentration of essential amino acids. Milking operations run in staggered shifts to maintain the herd's natural circadian rhythm. Sudden summer thunderstorms frequently trigger defense mechanisms and induce mass panic among the horses. Continuous perimeter patrols are required to maintain herd cohesion and prevent individual isolation.
Yeah, get on now, go!
Nighttime serves as a critical metabolic period for the livestock to rest, digest, and convert energy. Transitioning into autumn, the primary objective shifts to maximizing the animal's subcutaneous fat reserves. Biochemical changes in the drying autumn grass provide highly concentrated caloric intake for the livestock. A massive seasonal migration relocates this immense biological wealth toward wind-shielded winter valleys. Herds are systematically sorted based on age and health metrics to select optimal genetics for future breeding.
Hey, get in there! Move on now! Move! Keep them moving.
Coordinating
to the east.
tens of
Head for the
thousands of
riverbed.
horses requires precise
Press the left
logistical
flank
planning
forward.
of migration routes and watering points.
Steady now. Keep the herd moving east. Push the flanks. Let's go! Faster!
Livestock is concentrated around major unfrozen river basins to secure an unbroken water supply. Dropping temperatures trigger a biological response, causing the horses to grow a highly efficient thermal winter coat. Thorough physical assessments of the herds determine the strategic allocation of winter feed reserves. Migration routes deliberately utilize deep canyons to block the first incoming waves of cold Arctic air. This window is the final opportunity for the herds to stockpile energy before the deep freeze begins. The continental winter plunges the entire ecosystem into extreme survival mode at temperatures below -40 degrees Celsius. Horses utilize their hooves to break through compacted snow to access the frozen vegetation preserved underneath. Equine metabolisms automatically decelerate, conserving core energy strictly for vital organ function. Topographical basins are utilized as microclimate buffers to shield the massive herds from destructive wind chill. Low-speed movement is continuously enforced to maintain body heat and prevent joint crystallization.
We must keep
Navigating
moving.
blizzards
Do not
relies
stop.
entirely on spatial
way, follow
memory
me.
and a deep understanding of equine herd behavior. The animals instinctively cluster tightly together, creating a highly effective communal heat-sharing system. Vulnerable foals with underdeveloped thermoregulatory systems are isolated within insulated felt enclosures. High-density biomass concentration acts as the primary biological defense mechanism against extreme hypothermia. This brutal season functions as a rigorous natural filter, preserving only the most resilient genetic lineages. As temperatures rise, a massive, synchronized roundup campaign is initiated across the region.
Chuk! Hey! Get them moving! Aralda!
The gathering process requires multi-vector coordination among independent groups of riders to encircle dispersed herds.
Push them to the center! Go! Keep the line tight!
Livestock is funneled towards central processing hubs, transitioning from open grazing to the economic harvest phase. Heavy-duty wooden corral systems are engineered to absorb and disperse the mechanical pressure of the stampeding herd. Rapid anatomical dissection techniques are applied to completely separate muscle tissue from the skeletal frame.
Keep moving! Hold it steady. Let the first group pass. Keep the pressure on the gate.
The inflow of animals into the processing funnels is strictly regulated to prevent lethal trampling.
Steady now. Pull him left.
Specialized lasso techniques are deployed to swiftly isolate aggressive or highly volatile stallions.
Harder! Dig in!
The kinetic energy generated by wild horses pushes traditional organic ropes to their absolute tensile limits. Corral architectures feature narrow, unidirectional corridors that force the herd into automated, sequential lines. Livestock is rigorously classified according to economic criteria for specific industrial and agricultural applications.
Move! Get him in! Pull the chain!
This vast roundup officially terminates the free-roaming cycle, shifting operations into the processing phase.
Faster on the cuts.
Keep the line moving, we have more coming.
Check the freshness seal before crating.
Next one,
Biomass
quickly.
harvesting
Move it
is
to table
executed
5.
at maximum speed to guarantee the highest
this
level
section
of
now.
raw material freshness. Extreme surgical
next cart,
precision
quickly.
is maintained to prevent any cross-contamination
ready for
of the
freezing.
bone marrow.
Watch the temperature on line 3.
Faster, keep the line moving.
Check the temperature on that batch.
Next section, quickly now.
This process stockpiles essential protein and mineral reserves intended for human consumption throughout the year. Large-scale outdoor drying racks utilize the high-velocity steppe winds and low humidity for natural dehydration. Muscle
Make sure the
tissue is
strips are
sliced
thin
into
enough for
thin
drying.
strips to maximize surface
These are
area
looking good.
and accelerate moisture evaporation. Raw mineral salt is rubbed into the tissue, creating a hypertonic environment that completely inhibits bacterial growth. combination of sub-zero temperatures and dry wind extracts water without destroying the underlying protein matrix. Finished products are stored in aerated facilities to prevent moisture condensation and subsequent fungal growth. Femurs and large tubular bones, which contain the highest density of collagen, are meticulously isolated for extraction. The skeletal material is transported to glacial streams to undergo rigorous mechanical hydraulic cleaning. The extreme cold of the glacial water instantly halts lipid oxidation and bone marrow degradation. The high kinetic energy of the river current effectively strips away adhering soft tissue and organic residue. Complete
Section
removal
Gamma,
of surface
row 4.
impurities
Clear.
is mandatory
Wait,
to prevent
I
the
found an
final
impurity on this
collagen
pelvis.
solution from
It needs
turning cloudy.
rewashing.
This cold water hydraulic purification significantly elevates the chemical purity of the raw bone material. Scrubbed bones are spread across river stones to optimize drainage via natural air convection. The continuous flow of the stream ensures that all extracted biological waste is rapidly washed away from the processing site. Prolonged exposure to freezing water demands immense physical endurance from the labor force. Ultraviolet radiation from direct sunlight acts as a natural, broad-spectrum surface sterilizer. Thorough desiccation is critical, as low residual moisture significantly increases collagen yield during thermal extraction. Larch wood is selected as the primary fuel source due to its high fiber density and exceptional caloric output. The stable combustion profile of this timber maintains a flat, consistent temperature curve within the furnace. Logs are split to increase the surface area exposed to oxygen, thereby optimizing the chemical combustion reaction. Fuel supplies are strategically stockpiled around the facility to ensure an uninterrupted thermal feed. Ignition is achieved using highly combustible, naturally desiccated biomass native to the steppe. Thick stone furnaces act as thermal batteries, absorbing heat and radiating infrared energy evenly into the cauldrons. Air intake valves are continuously adjusted to regulate the exact volume of oxygen feeding the combustion chamber. Organic resins within the larch would sustain a highly intense, prolonged burn over several consecutive days. Negative pressure chimney systems are engineered to safely extract toxic flue gases from the enclosed processing facility. Furnace operators monitor flame coloration to assess thermodynamic states without the use of digital sensors. Collagen extraction takes place inside massive, industrial-capacity cast-iron cauldrons. Cast iron's high specific heat capacity prevents sudden temperature fluctuations during the boiling process. Bones are stacked in a porous structural arrangement to maximize surface area contact with the solvent. Pure glacial water acts as a polar solvent, efficiently dissolving hydrogenated polypeptide chains from the bone matrix. Sustained boiling temperatures systematically break down the rigid mineral bonds within the skeletal structure. The exterior soot buildup on the cauldron functions as a thermal buffer, distributing heat more evenly across the base. As minerals and gelatin diffuse, the clear solvent gradually transforms into a dense, opaque emulsion. Specific botanical compounds are introduced to balance the pH levels and enhance the biological activity of the solution. Heavy wooden paddles are deployed as the process transitions into the kinetic agitation phase. The rate of solvent evaporation serves as a visual indicator of the increasing molecular density of the collagen. This pressurized concentration phase demands a constant thermal input, with no permitted drops in temperature. Continuous mechanical agitation prevents the dense collagen mixture from precipitating and scorching at the bottom. The solution darkens into a deep amber due to Maillard reactions and the extreme concentration of solutes. Exponentially increasing dynamic viscosity requires significantly greater mechanical force to maintain the stirring rhythm. Uninterrupted water evaporation continuously drives up the mass percentage of pure gelatin in the mixture. A strict rotational labor system ensures the mechanical agitation rhythm remains absolutely uniform around the clock. Consistent stirring allows the biopolymer chains to align into a highly uniform structural matrix. Thermal shock tests using cold water determine the exact solidification threshold of the compound. Heat input is drastically reduced in the final hours to prevent the thermal denaturation of the protein structures. At this stage, the compound's viscosity reaches optimal saturation, signaling readiness for the molding phase. The molten suspension is poured through heavy linen filters to extract all remaining microscopic bone particulate. This pressurized filtration step is strictly enforced to guarantee the absolute structural purity of the end product. Mechanical compression is applied to the filters to recover every ounce of the highly viscous gelatin. The purified amber liquid is distributed directly into standardized wooden molds crafted from larch. Parchment paper lining creates an isolation barrier, preventing mechanical adhesion between the glue and the wood. Due to its high viscosity, the liquid utilizes gravitational pull to automatically achieve a perfectly level surface. Surface air bubbles are rapidly eliminated to prevent the formation of structural voids within the cooling gel. Molds are transferred to specialized cold rooms to trigger the phase transition from a liquid to a solid state. Decreasing temperatures induce the formation of hydrogen bonds, creating a highly resilient, elastic gel network. A mirror-like, flawless surface serves as the visual quality control metric for physical uniformity. The solidified blocks are carefully extracted from the molds once structural setting is fully complete. A taut silk thread strung across a wooden bow is utilized to slice the dense gelatin blocks. The micro-thin silk drastically reduces friction, yielding perfectly flat and smooth mechanical cuts. Internal structural homogeneity allows the blocks to refract light similarly to natural amber. Products are cut into standardized, uniform dimensions to optimize downstream commercial packaging logistics. Highly porous handmade paper is used for wrapping to meticulously control the surface humidity of each block. Natural hemp twine is tied securely, providing consistent mechanical compression to keep the packaging intact. Red wax seals are applied to officially certify the product's quality metrics and geographic origin.
Director. Every block certified.
Finished goods are packed into durable leather transit cases, engineered to absorb impact during global distribution. This closed-loop industrial cycle successfully converts raw steppe biomass into a high-value global economic export.